Good morning, this is Mr. Herman. This video, you're going to be learning about solving exponential equations with the same base. Now, we have not talked about solving exponential equations yet, so this is going to serve as an introduction. Later on in class on Friday, we will spend some time going over these videos to make sure that we have a good understanding of solving exponential equations. The first type we're going to look at is when we're solving with the same base. All right, so if we have an exponential equation that looks like this, 2 raised to the x plus 3 equals 2 raised to the 3x minus 1, we can see that these two exponents have the same base. Okay, we've got base 2 over here, we've got base 2 over here. Okay, so in order for these two expressions to be equivalent, our bases are good, those are the same, and then our exponents have to be the same. Okay, so the way that we can make those exponents the same is set them equal to each other. We take x plus 3 equals 3x minus 1. And there's a little two-stepper that y'all have been doing for years. Okay, we'll walk through it though. Plus 1 on both sides. So you have x plus 4 equals 3x minus x minus x. 4 equals 2x. Divide by 2 on both sides, x equals 2. Now, we won't have to do this every time, but let's go back in and check. So you have 2 raised to the 2 plus 3 equals 2 raised to the 3 times 2 minus 1. So you've got 2 raised to the 5th equals 2 raised to the 6 minus 1, 5th. Okay? So then that checks out. So we know that x equals 2 for this particular equation. Okay? We'll go ahead and do one more example. Let's say that we have a base of 5 and we are raising that to the 2x plus 5. And that's equal to 5 raised to the 5x minus 1. Okay? So we have the same base. Okay, we'll go ahead and underline those. Those are the same base. 5 and 5 are the same. Now if we have the same base, we know that in order to make them equal, we have to make sure those exponents are the same. Okay? The last time I saw our exponents made 5, we have to check them here, so we're just going to set our exponents equal to each other. 2x plus 5 equals 5x minus 1. Once again, we're just solving a good old-fashioned two-step equation. Add 1 to both sides. 2x plus 6 equals 5x. We'll subtract 2x on both sides. 6 equals 3x. Divide by 3. Divide by 3. X equals 2. Once again, you don't have to do this every time, but we're going to go ahead and check. Got 5 raised to the 2 times 2 plus 5 equals 5 to the 5 times 2 minus 1. So we got 5 raised to the, so we got 4 plus 5, so 5 raised to the 9th is equivalent to 5 raised to the 10 minus 1, 5 raised to the 9th. Okay, so that goes ahead and checks out. Now, if we were to write some steps here for when we solve with the exponential equations with the same base, they could be as follows. So if the base is the same, 1, set exponents equal to each other. 2, you'll solve the equation for the variable. Okay, now we're going to look at a few other methods going forward, but they're going to base on this idea that we have to make sure that our bases are the same, and then set our exponents equal to each other. We'll have to remedy that if they're not the same in our next couple of cases. All right, so go ahead and work out the problems on the next portion. of the lesson, and then we will be talking about this in class on Friday.